Hello students, welcome to DVS Math. Today continuing electricity class 10th. In previous session we discussed some important concepts related to electricity lesson. Today we are going to discuss some important problems in this lesson. So now problems means you know that using some formulas we are going to solve. So in this lesson we have many formulas. First let's see which are all the formulas which come across in this lesson. The first formula is I is equal to Q by T, which is nothing but the definition of current. What we say that rate of flow of charges. So I is equal to Q by T, where I is current, Q is charge, T is time. Next is V is equal to W by Q. So which is the definition of electric potential, or you can say potential difference. The work done in moving unit charge from one point to the another point, we are going to call it as potential difference. So V is equal to W by Q. That is V is potential difference, W is work done, Q is charge. Then from Ohm's law you all know V is proportional to I. So if we remove the proportionality symbol, we introduced one constant here R. V is equal to IR. R is resistance. So or you can write in terms of I is equal to V by R, or you can express in terms of R is equal to V by I. So this is the formula which come from Ohm's law. Then we have another one which is related to resistivity. So here, as you all know, the resistance depends directly proportional to the length, inversely proportional to the area of cross section. There, if you remove the proportionality symbol, we introduce one constant called as rho. So here R is equal to rho L by A, where R is resistance, rho is resistivity, L is length, A is area of cross section. And fifth is when resistors are connected in series. So at the time effective resistance will be Rs is equal to R1 plus R2 plus R3. That means we are going to add all the resistance together. Next, when resistance are in parallel, at the time we are going to take the reciprocal and we are going to add them. That is 1 by Rp is equal to 1 by R1 plus 1 by R2 plus 1 by R3. Seventh one, which is related to the heating effect, that is Joule's law of heating effect, gives that H is equal to I square RT. Here heat produced is directly proportional to square of current, directly proportional to resistance, directly proportional to time. So together we'll write H is equal to I square RT. The last, which is eighth formula, is power related, that is P is equal to VI. We are going to write it as rate of, here we are going to flow of charges, what we going to consider it as a current. Here we consider it as a power, the work done by the current, we are calling it as power. So for power we are going to express P is equal to VI in terms of voltage and current, P is equal to I square R in terms of current and resistance, P is equal to V square by R in terms of voltage and resistance. These are the important formulae we are going to use in electricity lesson problems. So let me understand one by one how are all the questions come in this electricity lesson and which formula we are going to use and how we are going to solve. So let's start first problem. An electric lamp draws a current of 0.3 ampere and it is used for 6 hours every day for a month. Month here they specifically mention that 30 days. Calculate the amount of charge that flows through the current every day and for a month. Here what they are given saying that an electric lamp draws a current of, here they gave I value, that is current value, that is 0.3 ampere. And how it is used 6 hours every day. The time it is 6 hours, but it is in hours, so we have to convert into seconds. So 60 into 60, how many hours? 6 into 60 into 60 we have to take to convert into seconds. Calculate the amount of charge means you have to find Q. So here what are all the given? I is equal to 0.3 ampere, T is equal to 6 hours. So if we convert into seconds, what you have to take? 6 hours, right? 6 into, for 1 hour it is 60 minutes, 60 seconds. So 60 into 60. So here I is equal to 0.3 ampere, T is equal to 6 hour. So 6 hour can be converted into seconds is 6 into 60 into 60 seconds. So now, as you all know, to relate it to the current, charge and time, we have a definition of electric current, that is I is equal to Q by T. So now using this formula we are going to solve. So if you substitute, so here we need, here the formula is I is equal to Q by T. Here what we have to find? Q. So we are converting that formula in terms of Q, that is Q is equal to IT. So here if I substitute, I is equal to 0.3 into time is 6 into 60 into 60. So 6 into 60 into 60. Here if you multiply 6 6 are 36, 36 6 are 216 into 0.3, you will get 6480 coulombs. Here remember, every time if you are going to find the value of any unknown term, you have to write the SI unit of that. So that also consists of marks here, that is also important. So Q is equal to what we got, the charges here, 6480 coulombs per day. Here it is for per day. So we have to find for 30 days. For 1 day it is 6480 coulombs. So what happens for 30 days? That means you have to multiply by 30. So 6480 into 30, you will get 1,94,400 coulombs. So for 30 days, there is a flow of charges is 1,94,400 coulombs. So every time you observe, using the data, write the given, which are all the given and which you has to find. So using that, relate the given and write the suitable formula, substitute it, simplify it and write the final answer in terms of SI units. Clear? So let's move on to second problem. So here, how much work is done in moving a charge of 2 coulomb across 2 points having a potential difference 12 volt. So as soon as if you see this, 2 coulomb means they have given the charge, that is Q. 12 volt, that means they have given voltage V. So charge V, they are asking work, so W. So what is the given? So Q is 2 coulomb, V is 12 volt, W. So which is the formula which relates all this? So our formula is the definition of potential difference, that is V is equal to W by Q. So now here we need to find W. So generally, if you convert that in terms of W, it is cross multiply VQ. Just substitute it. V is 12, Q is 2. So 12 2s are 24 joule. So work done in moving 2 coulomb of charge in potential difference 2 volt, it is 24 joule. It is a very simple and they may ask for 1 mark this question. So remember, let's move on to third. When a 12 volt battery is connected across an unknown resistor, observe, when 12 volt battery is connected across an unknown resistor, there is a current 1.5 ampere in the circuit. Find the value of resistance of the resistor. So here 12 volt battery is nothing but a potential difference, that is V, that is 12 volt. And in that resistor, how much current is flowing here? 1.5 ampere. So we have to find the resistance, that means R. So if we write the given, V is 12 volt, I is 1.5 ampere, we have to find the R. Resistance means R. And remember, which is the formula which relates all three from Ohm's law. So which is our Ohm's law, that is V is equal to IR. So here we have to find the R. So if we convert that in terms of R, R is equal to V by I. Now substitute it, 12 by 1.5. So 12 by 1.5, we will get 8. So it is R is equal to 8 ohm. The SI unit of resistance is ohm. Or you can write OHM, or you can write in terms of symbol here. So this is about so first write the given part, V, I and R. So what is the formula which relates all these three from Ohm's law? V is equal to IR. You have to find R, V by I. So R is equal to 12 by 1.5. So if we divide that, R is equal to 8 ohm. So this is about the third problem. So let's move on to next. So next is calculate the area of cross section of a wire of length 1 meter. Its resistance is 23 ohm and the resistivity of the material of a wire is 1.84 into 10 to the power of minus 6 ohm meter. So if you observe this, here the wire length of wire is nothing but L given, that is 1 meter, resistance 23 ohm, and they gave the resistivity. As you all know, what is the symbol of resistivity? Rho. So rho is equal to 1.84 into 10 to the power of minus 6 ohm meter. They are asking to find the area of cross section we are representing in terms of A. As you all know, this is the given part is consists of L, rho, R, A. So which is the formula we are going to use? The formula of resistivity, that is R is equal to rho L by A, as you all know. So now we need to find A value. So we are converting here. Here observe. So if we consider here, the formula is like this: R is equal to rho L by A. So you need to find the A. So I am sending R to this side LHS and A to LHS, R to RHS. So it becomes rho L by R. Rho L by R. So now let us substitute. Rho, it is 1.84 into 10 to the power of minus 6 into what is the L value? 1 divided by 23. So now keep it 10 to the power of minus 6 as it is. Just you divide 1.84 divided by 23, or just you can divide 184 by 23. Afterwards you can shift the points. So if you divide 184 by 23, you will get 8. 23 8s, it is 184. So now there are 2 points. So if you take 2 digits, you will get 0.08 into 10 to the power of minus 6. But here they are asking area. The SI unit of area, it is meter square. So this is about the fourth question, which is related to the resistivity. And remember, here they are asking the value of A. Sometimes they will ask the value of L. Sometimes they will ask value of R, resistance. So using the same formula, just we are converting to the related to the what is given and what we have to find. So relating to that, we are converting this formula and we are substituting and simplifying. And don't forget to write the SI unit. So next, 3 resistors of resistance 2 ohm, 3 ohm and 6 ohm are connected in series as well as in parallel. Find the effective resistance in both cases. So observe here, there are 3 resistors. One is 2 ohm, 3 ohm, 6 ohm. They're saying that these 3 resistors are connected in series. After that, they are connected in parallel as well as parallel. So we have to find effective resistance in both cases. So as you all know, let us write the given: R1 2 ohm, R2 3 ohm, R3 6 ohm. You have to find RS and RP. So now first let us find RS. First in series, in parallel. First see here step by step. So now in this, in series, if we go, as you all know, if it is connected in series, just adding all the resistors together, you will get the effective resistance that is connected in series. So now here observe, if we consider RS is equal to R1 plus R2 plus R3, just you add it. So 2 plus 3 plus 6, so you got RS is equal to 11 ohm. 11 ohm. So now if it is connected in parallel, so as the formula 1 by Rp is equal to, here you have to take Rp also the reciprocal. You can't write Rp is equal to 1 by R1 like that. So here you have to take the reciprocal of Rp also. So 1 by Rp is equal to 1 by R1 plus 1 by R2 plus 1 by R3. So if we substitute R1, R2, R3, you will get 1 by 2 like this. 1 by 2 plus 1 by 3 plus 1 by 6. So together if we consider what is an LCM, 6. So here if you take 2 3s are 6, so 3 2s are 6, so it is 2. So and 6 ones are 6. So 3 plus 2 plus 1. So we'll get 3 plus 2 plus 1. It is 6. 6 by 6. Again you want to find the RP here. If you consider RP. So RP also here you have to convert this LHS here denominator to numerator, numerator to denominator. Again it becomes 6 by 6 only. See, 1 by RP is 6 by 6. If you want to find, sometimes it will be like, for example, if I consider, observe here the value. So now for example, if I consider 1 by RP is equal to 4 by 5, just 4 by 5. So now you need to find RP. At that time just interchanging 5 by 4. So here the both numerator and denominator both are same. So no, if you change also there is no difference. So 6 by 6, what is 6 by 6 value? 1. So here the effective resistance when connected in parallel, it is 1 ohm. So when it is connected in series, just add all the resistors together. When it is connected in parallel, just take the reciprocal for each, even the effective resistance in parallel also. 1 by RP 1 is equal to 1 by R1 plus 1 by R2 plus 1 by R3. So taking LCM, find out, then change the denominator and numerator to get RP. So at that time if you divide it, you finally will get the value of RP. That means resistors connected in parallel. So let's move on to next, sixth problem. So sixth problem, how can three resistors of resistance 2 ohm, 3 ohm, 6 ohm be connected to give a total resistance of a 4 ohm and 1 ohm? Here they are not saying how they are connected. So observe, this is a very important thing you have to remember. If you have only two resistors, observe, if you have only two resistors, how we can connect? Either here, either you can connect like this, R1, R2, right? So they are connected in series. Or if it is, or either you can connect like this, right? Like this, parallel, R1, R2, right? So if it is only two resistors, remember, if it is only two resistors, you can connect in series or parallel. There is no option. Clear? But here if you have three resistors, if you have three resistors, we have four options. Please observe carefully. When it is only two resistors, either you can connect in series or either you can take it as parallel. But if you have three resistors, we have four options. Observe here. The number one, all three you can connect it in series. See here, observe, all three you can connect in series. We have four options. First option, you can connect all three in series or all three in parallel. If it is three, first option is you can connect in series, all three in series, or all three in parallel, or observe, this is very important here. So observe here, or one is series, another two is parallel. One series, two parallel. One series, two parallel. Or two series, one parallel. So here these are all the four options that you can connect the three resistors. So if it is three resistors, we have four options. Number one, all three in series, like this, first option. Or all three in parallel, like second option. Or one series, two parallel, like third option. Or two series, one parallel. So here they are not saying how it is connected. We have to find how it is connected. Observe, they are already given the effective resistance. One is 4 ohm, another one is 1 ohm. Just we have to find how they are connected. Observe, if it is all in series, observe, if it is, for example, if I consider first option, all are in series. If all are in series, what we will do, just we will add all the resistors. If we add 2 plus 3, 5, 5 plus 6, 11. So is there 11 is the answer in here? No. That means this is not. So they are not connected all in series. Clear? Then all are in parallel. All are in parallel. If you connect all are in parallel, so 1 by 2 plus 1 by 3 plus 1 by 6, again LCM. So if you take 3 plus 2 plus 1, so 6 by 6, 1. So here we have option 1 ohm. So the second, so B 1 ohm we are getting. So the second, it is connected in parallel. What about 4 ohm? 4 ohm we will get when, so already we have 2 ohm, right? So let's start here. Let's write the given. So R1, R2, R3. R1 is 2 ohm, R2 is 3 ohm, R3 is 6 ohm. Let us write the formula. What is the formula? First we are taking the B1. So B is easy, right? So B is easy. Just we find out all are in series. So if you substitute all are in series, you got 1 ohm. So remember, when we get a 3 resistors, you have 4 options. All are in series, or all are in parallel, or 1 series, 2 parallel, or 2 series, 1 parallel, if they are given 3 resistors. So here option B, we got effective resistance 1 ohm. So here all resistors are connected in parallel. If they connect in parallel, we will get 1 ohm. What about first case, 4 ohm? First, what we have to do, 3 and 6 are, they are factors of each other, or even 2 also, but 3 and 6, they are factors of each other. First, let them connect in parallel. So if they connect in parallel like this, in third case, first R2 and R3, let them connect in parallel. That is 1 by Rp is equal to 1 by R2 plus 1 by R3. So that is 1 by 3 plus 1 by 6. 1 by 3 plus 1 by 6, you will get, what is an LCM you will get? So LCM is 6. So 6, it is 2 plus, you will get 1. So 3 by 6. So what is 3 by 6? 1 by Rp you will get 3 by 6. It is 1 by 2. 3 ones are 3 twos are. So here 1 by Rp is equal to 1 by 2. But what is here left with R1? We have one more resistors 2. So let me connect. So observe clearly here. So let me understand it, make you understand better. So now, so first they are doing like this. So here R2 and R3 are in parallel. So finding the effective resistance between these two, that is 1 by 3 plus 1 by 6. So 1 by 3 plus 1 by 6, you will get 3 by 6. If you divide it, you will get 1 by 2. But 1 by Rp is 1 by 2. What about Rp? Rp you will get 2, because if you change numerator and denominator, you will get 2. But we have 4 ohm. So if we add another remaining 2 ohm to this, you will get 4. So when we will add together, 2 together, so when it is in series, that is here R is equal to R1 plus Rp. So 2 plus 2, you will get 4 ohm. So this is about when 3 resistors are given, we have 4 options there in their connectivity of resistors. So clear? So we'll move on to next question 7. An electric iron of resistance 20 ohm takes a current of 5 ampere. Calculate the heat developed in 30 seconds. So now here if you write the given part, I, they have given 5 ampere, R is 20 ohm, time is 30 seconds. You have to find H value. Observe, heat developed means here we are using the formula Joule's law of heating effect. What is that formula? H is equal to I square RT. So now substituting, I square means here you have to square the value of I. Here what is the value of I? 5. So 5 square means 5 into 5. So R it is 20, T it is 30. 5 5 is a 25, 25 2 is a 50, 50 3 is a here 150, so remaining 2 zeros, so 15,000 joule. So as you all know, heat is also heat energy, we call it as. So it is calculated in terms of joule, so we are writing SI unit as joule. So 15,000 joule. So first write the given. H is equal to I square RT. H is equal to 5 into 5 into 20 into 30. So it is 15,000 joule. So next, 8th one, a lamp rated 100 watt at 220 volt is connected to the mains electric supply. What current is drawn from the power line if the voltage is 220 volt? The here voltage is same in all these cases. If you can consider the lamp, or if the main voltage, it is 220. So let us write the given. Here given watt we express in here in power, right? So power is equal to 100 watt. Voltage in both the cases it is 220 volt. Here we have to find the current. So what current they are asking? So I. So what is the formula related to power? V and I, that is P is equal to VI. So here we have to find I. So I is equal to P by V. I is equal to P by V, that is 100 by 220. So 0 0 you can cancel 0 and 0, it becomes 10 by 22, or it can simplify 5 by 11. So finally it becomes 5 by 11. If you divide 5 by 11 you will get 0.45 ampere. So I is equal to 0.45 ampere. So here first write the given. So and remember you have three formulas for P. P is equal to VI, P is equal to I square R, P is equal to V square by R. So depending upon the given, select the formula. Going for next, ninth one. In the circuit diagram given, so observe the circuit diagram and all the three resistors are connected in parallel and the battery of 6 volt. So let me question the total, calculate the total current in each resistors, the total current in the circuit, total effective resistance. The current in each resistor, as you all know, here current varies in parallel. As we go on difference between series and parallel, current remains same in series, current varies in parallel, but voltage varies in series, voltage remains same in parallel. So here current is different in each resistors. So they have given the V value. So if we write the given, R1 is 2 ohm, R2 is 5 ohm, R3 is 10 ohm, V is equal to 6 volt. So first let us find current. As you all know, formula from Ohm's law, V is equal to IR. So I is equal to V by R. So first find the I1 which is flowing in first resistor. So that is I1 is equal to V by R1. So V is common here. For voltage is common for all the resistor, as voltage remains same in parallel but current varies. So I1 is equal to V by R1, that is 6 by 2, which is 3 ampere. So that means 3 ampere of current is flowing in first resistor. In second, I2 is equal to V by R2. So let us, okay, here I2 is equal to V by R2, just changing the resistor values. So V by R2, that is 6 by 5. So R2 it is 5 ohm. So 6 voltage is same. So 6 by 5 it is 1 by 2 ampere. I3 V by R3 is equal to 6 by 10 is equal to 0.6 ampere. So now these are all the current in each circuit, that is 3 ampere, 1.2 ampere, 0.6 ampere. So why it is, and observe the current is decreasing here. In each case 3 ampere and 1.2 is less, 0. And observe the value of the resistor here. If we consider the value of resistor, in all the cases it is more. As you all know, the resistance is more, current flowing will be less. So here in 2 ampere the resistance is less, so your current is 3 ampere. So in second case 5 it is more, so it is current reduced 1.2. Again 10 ohm is more, so again current reduced. So this is about the current flowing in each resistor. What about the total current? Means just you add all the current which is in all the resistance. That is, if you add all these, you will get I is 3 plus 1.2 plus 0.6. Finally you will get I is equal to 4.8 ampere. Clear? So then what you have to find? The effective resistance, total resistance, and observe all these resistors are connected in parallel, that is 1 by Rp is equal to 1 by R1. So if it is parallel, you have to take the parallel formula. 1 by Rp is equal to 1 by R1 plus 1 by R2 plus 1 by R3, that is 1 by 2 plus 1 by 5 plus 1 by 10. So if you take LCM is 10, so 2 5s are, 5 2s are, 10 1s are. So 5 plus 2 plus 1, that is 8 by 10. And you remember here you want the value of Rp. So we are changing denominator, numerator 10 by 8. If you divide 10 by 8, you will get 1.25 ohm. So in parallel, find the individual current in each case, and all together if you add all the current, you will get total current in the circuit. And if they are parallel, using the parallel formula, find the effective resistance in the circuit. So we'll go for last problem. Two lamps one rated 100 watt at 220 volt and another rated 60 watt at 220 volt are connected to electric main supply, what current is drawn from line if supply voltage is 220 volt? So observe here we have two lamps of different power. So let's write the given. P1 100 watt, P2 60 watt, V is 220. In both the cases voltage is same. So first we have to add both the power together. P1 plus P2 is equal to 100 plus 60, it is 160 watt. And as you all know, here again they have given power, voltage, and they are asking to find the current. So what is the formula related to all three? P is equal to VI. So here we have to find I. So I is equal to P by V. So if you substitute 160 by 220, 160 by 220. Here first cancel 0, 0, 16 by 22. Again you will get, if you divide by 2, 8 by 11. So if you divide 8 by 11, you will get 0.72 ampere. So here we have and in this lesson solving the problems are very easy. So first observe the question, write the given and select the formula which is related to the given. Substitute it and simplify it. Finally you will get the answer, and don't forget to write the SI unit. For more conceptual learning, subscribe my channel and keep watching. Thank you.